Okay, in the third technique, we're going to detect the contour line or detect all the faces that are undercut on the mesh by just a brute force test of the normal. So what that looks like, this is in D3 Splint. When we go to survey the model, we capture the view direction, and then we test every single face against that view direction. And faces that are pointed even a little bit away from it, we shade in dark, and faces that have any component with their normal pointing towards the view direction, we shade light. Okay. Then what we do after that is you go through and you test every edge and say, okay, are your neighbors both facing towards or both facing away, or do you have one on each side? And so when you find all the edges that have one face facing towards and one face facing away, even if just by a little bit, you found the height of contour. Okay. In a lower res model like this, it's not as precise, although this is fine for making of splints. In a little higher res model, that line can actually be very precise. Okay, I first started playing with this in March 2013, and that's around the same time that the built-in Blender 3D print toolbox came out, and the 3D print toolbox would detect undercut faces and sort them by their angle in terms of how far away from the insertion axis they were pointed. Okay, and then I did an implementation that tested everything and then found the edges which represented the contour line. So you can read about those here and here. Then later on what I did is, if you extrude that, let's see here, if you extrude that contour line downward, I'm going to pause the video here and bring up a second example. So a partial implementation of this technique is built into D3 Splint. It doesn't give you anything useful, but it does show the potential, okay, because the undercuts are very precisely blocked out, and the error at the rest of the model is 0 because it preserves the actual original data. Problem is, it just drops these faces down, so it doesn't really know exactly what to do after that. So to go from here to a closed model is kind of difficult. But I think that this is ultimately the technique that I'm going to revisit for undercuts. If you look there, I mean, the precision of that compared to our projection grid are just far and away much better. And I guess we could, if we were good scientists, we could quantify how much better. Okay, so that is the, I would call that brute force undercut detection and removal. And because hardware has gotten much faster and the data structures in Blender for BMesh are fairly efficient, this is a good one. So they're fast, detects the contour line very precisely, to the resolution of the scan, but it's difficult to create a manifold mesh. And I think that with some cleverness later on, we will be able to do some remeshing and some other clever things to where we end up getting a nice result.